Hi there. In today's video, we're going to play a little game called What Would You Rather? Now, in this scenario here, you have the choice of being thrown hot boiling water at you, okay, or you could be hit with steam that's at 100 degrees Celsius. So the choice is yours. One of these will actually hurt so much more than the other. So let's look at the scenario. Let's say you're just an average person, minding your own business, and let's say a friend of yours, okay, who's a little bit evil, he decides to throw a bucket of water at you, okay, but because he's evil, it's going to be hot boiling water, okay, so he's going to throw water at you, it's going to splash all over your face and body, okay. We're going to say that this person has about 1,000 grams of water. Okay. And because it's boiling, it'll be 100 degrees Celsius. 1,000 grams is 1,000 milliliters, okay, which is a liter of water, of hot water. On the other scenario, you have most likely yourself to blame. Okay, so let's say you have a pot, you're cooking something, maybe ramen, and you're curious to see if it's ready. So you open up the lid. Okay, and when you open up the lid, hot steam comes flying out at you. Yay! And it burns you. Let's say that this is a lot of steam. Let's say that you have also 1,000 grams of steam. That's also at 100 degrees Celsius. Which would hurt more? Which would cause you more serious injury? So let's break this down a bit. When you pour water over someone, okay, that water will eventually cool down. Okay, and your body temperature is about 37 degrees Celsius. On the surface, it's anywhere between maybe 25 to 27 degrees Celsius. So let's say that because the temperature started at 100 degrees Celsius, okay, and you're T2, the water cools down to, let's say, 25 degrees Celsius. That's a change in heat. Okay, so delta T is the change in temperature. So that's a change in temperature of 75 degrees Celsius, or to be more accurate, minus 75 degrees Celsius. And it'll be the same for the other side as well. Okay, you're basically having the same delta T here. Okay, it goes from 100 degrees Celsius down to 25. So we'll say that the changing heat is also the same amount. But the amount of heat given off is not equal though. Okay, so what you have to keep in mind is whenever there's a temperature change, you want to use the CP formula. So it's always mass times delta T times CP. And this one here is also Q equals mass times delta T times CP. But the difference is the CP values. Okay. This is going to be the CP for water because you started with water, and water CP is 4.18 joules per gram degree Celsius. But here, you start with steam. Steam CP is only 0.02 joules per gram degree Celsius. So if all of your other factors are the same, and the only difference is the heat capacity, okay, we're saying water can store a lot more heat than steam can. If that's true, then 1,000 grams of water, changing its temperature by 75 degrees Celsius, with a heat capacity of 4.18, it would give you a Q value of, oops, what happened? I'm sorry. There we go, we're back. It gives us a Q value of minus 313,500 joules of heat energy being released. So that's what the negative sign means. Over here on this side, we have 1,000 grams of steam. The temperature change is the same. Okay, changed by 75 degrees Celsius or minus 75 degrees Celsius. But we're going to multiply all that by a smaller specific heat value. Okay, and that comes out to be roughly minus 151,000 joules of heat energy. Okay, so between the two, it seems like water is going to hurt a lot more when it's thrown at you by your evil friend than being burned by steam alone. But there's one thing that you're forgetting. When the temperature of steam gets below 100, what happens to it? It turns into water, right? Because at 99 degrees Celsius, you don't have steam, you have water. So what we also have to factor in here is the amount of heat from the phase change. So since we're talking about a gas turning into a liquid, okay, we have to take the mass of the substance that we have and the negative heat of vaporization value, okay, or negative HVAP. So in this case here, it's 1,000 grams of 1,000 grams of steam, and you're multiplying by negative 2,260 joules per gram, which is the HVAP of steam. Okay, steam to water. That value alone gives you minus 2,260,000 joules of heat energy being released. So when you add these two numbers together, okay, you will get a total amount of heat energy of minus 2,411,000 joules of heat. Okay. This is quite a bit more of heat energy than from the hot water. Okay. If we wanted to figure out exactly how much more, we just simply take the amount of heat energy released by steam and divide by the amount of heat energy released from the hot water. And that gives us roughly 7.69, which we can round to about 8 times more heat. 8 times more heat will be given off by steam at 100 degrees Celsius than water at 100 degrees Celsius. So because of that, sometimes people say you get burned twice by steam than by water alone, or hot water alone. Because you get burned once from the temperature change, and then you get burned twice by the phase change. So if you had a choice, I would take the water any day, okay, opposed to being burned by steam. All right, have a good one.